We're solving problem 23 from the 2020 AMC 12B. How many integers n greater than or equal to 2 are there such that whenever z1 to zn are complex numbers such that absolute value of z1 is equal to the absolute value of z2 is equal to ... is equal to the absolute value of zn, which is 1, and z1 plus z2 plus ... to zn is 0, then the numbers z1 to zn are equally spaced on the unit circle in the complex plane. For this problem, we can start by testing really small values. So if n was 2, which is the lowest value, well, we can immediately see that z1 and z2, they can sum to 0. And if this is shown on a unit circle in the complex plane, we have a unit circle here. For all these roots, it's just going to be like opposite to each other. So they have to sum to 0, and this works. Let's look at n equals 3. Well, we have 3 complex roots this time on the unit circle. We don't know if this will work or not, but let's just see. If we have 3, right? Well, the one thing we can form that does work is an equilateral triangle, where since they all have equal sides, they sum to 0. And this indeed is true. They form a triangle sort of in the complex plane because all three these roots sum to 0. So we know that these two work insofar, right? So far, we know they work. Now, n equals 4. Well, n equals 4. If you have 4 roots, they sum to -1, z1 plus z2 plus z3 and z4 sum to -1. And this case does not work. And a way to visualize this is, well, there's no way to place 4 roots on a complex plane such that they're all equally spaced out and they're opposite to each other, and they cancel out on the complex plane. So it goes up to 4, where 4 does not work. So the only 2 working values we'd have is n equals 2 and n equals 3. Since the problem asks how many integers are there that are equally spaced like this, only n equals 2 and n equals 3 are integers, so 2 integers, because 2 and 3 is 2.